I'm Stuart Ashby, and today I want to talk about why I believe pipelines are silo busters. At BMC, I'm a DevOps specialist where I'm responsible for evangelizing enterprise DevOps and helping customers develop and nurture enterprise DevOps ecosystems. Prior to BMC, I worked as a DevOps engineer stroke architect in a UK retail bank. And I've got extensive enterprise knowledge that I've acquired working on the mainframe for over 30 years. At BMC, we believe that to evolve to an autonomous digital enterprise, companies in every industry should consider a transcendent customer experience. And what does that mean? Well, that's the ability to provide the best possible system of engagement for your customers, whether they're internal or external customers. A data-driven business operates with a data mindset and analytical capabilities that enable new revenue streams. And adaptive cybersecurity is the evolution of security functions that can automatically sense, detect, and remediate. It exploits AI-enabled solutions, applies DevSecOps, and adopts mature access and authentication practices with a zero trust framework. But today I'm going to focus on automation and enterprise DevOps. I believe that we in the mainframe community have been really good at automating manual tasks for years. However, as smarter off mainframe technology has come along, there have often been manual, clunky, or convoluted solutions to interact between mainframe and other platforms. I can remember engineering systems that would write a message to the console, automated operations would intercept that message, potentially start a batch job using different credentials to get access to something. And whilst that was good, it's a lot of maintenance for people to keep on top of as I'm handing over to the next gen or person that's replacing me. So now with RESTful API and command line interfaces, it's possible to script pipelines that cross-platform seamlessly so that we can use best-of-breed tools in the software delivery lifecycle toolchain. The right technology hosted on the most effective platform means that mainframe inclusive enterprise DevOps is a reality. I can remember working at an organization where our problem and change tool was hosted on the mainframe, a product called Infoman. And back then it was possible to interact from mainframe address space to mainframe address space. But now with API enablement and cloud hosted ITSM tools such as BMC Helix or ServiceNow, data can be shared, such as test evidence. I always had to make sure that my change records have test evidence on them. So we can share that data from a mainframe execution into the cloud ITSM tools without needing cut and paste or any kind of repeat activity, manual activity. So we've got simplification and automation as part of the process. So at BMC, we've done case studies with our customers, and what we see is that the return on investment from enterprise DevOps brings benefits for the development teams. By improving the developer experience, we can see that they can release new features and functions with higher quality more frequently. That gets value into the hands of your customer, again, both internal and external, much sooner. And it empowers teams to innovate and maybe that innovation is new feature or function, or maybe it's to address some technical debt. But it's always about being able to spend time innovating, not just constantly in the middle of engineering more. In the past 6 months, BMC commissioned a couple of research companies, Dimensional and Forrester, to do some work for us, looking at the state of mainframe tooling. And dimensional research showed that 96% of organizations are reporting challenges because of a shortage of mainframe skilled resources, and that mainframe application changes and development take too long. The mainframe's also being siloed from other DevOps initiatives. Forrester found that 8 out of 10 mainframe developers stated themselves that they need significant improvement with the development tools if they are to be effective. The dimensional research found that 40% of companies report they're using modern DevOps tools for all key phases of mainframe software delivery lifecycle, which is brilliant, because from that you can conclude that some companies are investing in their development staff. 77% of those surveyed agree that modern tools do increase velocity by 18%, and 62% say it will increase quality by 23%. So a lot of figures, but what it does show is that where companies have invested in modernizing the tools, and where their developers have been asked about would they want modernization of tools, it's an emphatic yes, that by improving all of the available features and capabilities, that things are going to get better for the developer, and perhaps they're going to make some magic happen. Forrester also questioned people who identify as developers, and it uncovered, that they believed that there were some issues because their tools weren't up to date. The tools themselves become friction points rather than the lubricant in the delivery lifecycle, and code may not be as secure as it could or should be. Debt may increase because the existing applications aren't modernized. The automation of manual tasks can't easily be achieved, and the customer experience is impacted because the application handoffs aren't streamlined. So with those tool statements in mind, I want to look at a typical release process, and this is where this is my interpretation of from my experience of a typical release process. And the software delivery lifecycle has been defined, the route to live is there, and a tool stack is in place. So developer knows what they need to change, and that the change has got to be promoted through the lifecycle. But there are manual handoffs, there are multiple interactions with support teams and other processes that are there. And the code gets through the life cycle at the speed of the handoffs and the speed that staff availability allows. So you get the code into production when each step has been completed naturally, and it's running at the resource availability maximum speed. Now, what happens if we consider using automation so that we get a virtual but experienced code reviewer, a database administrator, some code or release management team, and some testing resource sitting in the virtual box doing this automatic deployment at the speed that an experienced resource can't match because it's going that fast. So BMC provide Jenkins plugins for AMI Change Manager and SQL Explorer, along with plugins for ISPW, source control, and Topaz automated unit test. So you have the capability of automating the manual steps, and it can be invoked as self-service. Segregation of duties is critical if you're going to make some schema changes. So if a DBA is responsible for the availability and stability of any databases, they have to make sure that the code is reviewed and it goes into production post-review. So in the pipeline, it's still possible to automate the sending of an email, or in Jenkins to stop the pipeline waiting for a segregate, an additional resource to say, yes, this is approved to go. So it isn't about removing any kind of audit capability or compliance. It's about automating the manual activities, keeping within compliance regulation boundaries. So having established what the process looks like from a tooling point of view, I just want to touch on something that I do with a lot of customers, and it's called a value stream mapping process. So in that, we bring together all of the people involved in any kind of process and walk through the steps that are required, how long each of them takes, how long potentially the handoffs are waiting for. So we're talking about process time. That's the time that people are, or service time is the time that people are productive, and the wait time is whilst you're waiting for someone to read the email or be available to do the work. And by doing this, we can start to create a baseline measurement. We understand what the process is and how long it takes currently. Then as improvements are made, automation is introduced, the measurement can be retaken. And the advantage of that is you see what you're getting as a return on investment of that automation, which is critical if you're going to look for further funding, to be able to say, we have saved X amount of whatever the measurement is, so that that time can be used elsewhere. And now this is what I want to do next. So in this value stream, kind of an example, a bit of a hybrid from many of the companies that I've spoken to, the developer changes the code and requests a code review. So they might have to wait 8 hours for that to happen. The code review takes some time, it gets done, and then it's over to the project manager, who has to do some admin work to get a DBA involved, maybe tee up teams further downstream. But then there's some waiting time there. The DBA gets involved, and they're doing their process, and then they might pass it back to someone else, and the release and SCM team can make the code continue on its journey towards production. It's back to the DBA to do some more data work, maybe populating something with obfuscated data, or just getting involved after the code review, after the code promotion has happened. And then once that's happened, the test team can get involved, and then the journey is complete. And here, in my example, the service time was 44 hours, the wait time was 44 hours. So that has a process efficiency of 50%. As I say, it's not an exact science in this example, but when I'm doing it with customers themselves, it would be an exact science. You would get an exact idea of how long each of those handoffs are. And it's also bringing people together, possibly for the first time, to understand what each of the teams does. So we're preparing to create the pipeline, and we're breaking down the silos at this point by bringing all the teams together. So once we've done that, we could look at what it would be if we'd put all of those steps coded into a pipeline. So here in this, I've assumed that the pipeline is initiated when code is committed to version control, and then that initiates the pipeline to carry out the code review, the schema change, the code migration, and some testing, all sequentially when the previous step has successfully worked. And it might be that overall it takes more than 30 minutes in some instances, but actually I picked this because one customer that I work with tells me that this is the sort of improvement that they've seen as they've innovated and developed their pipelines further. So from something like 88 hours down to 30 minutes, I hope that helps everyone to understand that pipeline automation is where the value of having modern tooling is realized, because the handoffs have happened through API and it's seamless from code, commit, through all of those steps to exiting testing. If I just zoom into each of the steps that potentially could be in the pipeline at a really technical sort of level, I'm a Jenkins guy, so you're going to see a few references here that mainly are around Jenkins. And the first step with the Jenkins pipeline is that you're gonna copy some of the things into the workspace, so that you can have the default information, and perhaps it'll tell you what the life cycle looks like, so that the scripting can pick up variables, modify JCL for submission, or whatever the variables, wherever they're used. But I've got it all in the workspace, so I've got the base information that I need. I can then use the AMI compare utility to look at what the current database schema, and this is DB2 because that's what I'm most comfortable with. But it's looking at the current schema and comparing it to the desired schema, so that all of the artifacts can be created in advance of the change happening. And here we're reducing the effort and reliance on an experienced DBA by automating it. That DBA doesn't have to worry about a relatively minor change, or even if it's a major change, it doesn't have to be involved, because we're only down in the test environments or the dev environments. The automation then actually deploys the schema change, does whatever it needs to do to make the data viable for post schema change, and it can also prepare the rollback information in the event that something goes wrong and we don't want to have this change staying in the dev environments. And then quite recently, BMC released AMI SQL Assurance, and this ensures that SQL standards match site standards. The code is in the correct format. The access paths aren't going to be expensive to run, and there's logging there for feedback to the requester. So in my previous life, I can remember that we had a similar process to this, that when the code was just about to be released to production, anything that had SQL in it would be passed to the production DBA team, and they would review it to make sure that it was production ready. And then if they had any observations that needed addressing, it might go as a warranty defect that would have to be fixed within a period of time. But if they were major issues, the delivery team would have to make the changes at the 11th hour, right before the change record was going to be committed to going ahead to the change board. So all of these things would then be dependent on SQL being amended, potentially the code being recompiled, retested, all at the very last moment. So by having it shifted left into the development phase of any process has got to be a good thing. And the other thing that I can remember was, you were often asked about how many times has this been deployed before, and almost always the answer was never, because we never had the ability to bring everyone together to do those deployments. Whereas with the pipeline, we were effectively practicing the production implementation much, much earlier. So if I got asked that question now, I'd be able to say, we've done it 10 times, 5 times, whatever the answer is, but it's not going to be never. We'll have already done the deployment once before. So having updated the schema, I might be ready, preparing to extract the test cases from source control, and then I can execute the tests to make sure that the code behaves with the new schema and the data as it should do. And I can also measure code coverage to ensure, one, that I'm actually testing the code that I've changed, but also code coverage can be one of those forensic pieces of information, so that if something does go wrong at production implementation, that code coverage information could help understand why the testing was successful, but in production it wasn't successful. And then I can pass the code and the code coverage report onto a tool like SonarQube to make sure that I can do static code analysis. So my standards are good for the code, and I've got that analysis of the code coverage against a baseline of code, making sure it's not getting worse. And if at any point in this pipeline one of these steps fails, then we can provide feedback to the developer themselves to make sure that they understand what went wrong, get it fixed, commit the code again, and restart the pipeline. They haven't had to waste any other human time. This could be done when the developer feels comfortable, or if they want to experiment a little bit to make certain that the direction they're going is going to work. This brings the empowerment because it's all self-service. Let me dive into actually what it would look like in a Jenkins view. So the great thing about Jenkins is that along the way you can actually see the output. So here is a snippet of the output from that Amy compare step that is looking at the source and the target DDL to make sure that it can do the tool can make the changes required. And then we could go on to having 4 eyes or some kind of segregation of duties, approval. An email gets sent to someone, and then they're being automatically notified of change. The SQL assurance step, making sure that the SQL is production ready and isn't going to be too expensive to run. And then we get into Sonar, and the hyperlinks are included within the log, so that if an individual wanted to go and check, they don't have to Alt and Tab and then start a browser and go through all of the activities there. They can click on the hyperlink and it will take them to the report directly. So from code commit or pull request, the whole process is automated with the feedback provided to the developer. In the way that a developer can work where they want and when they want, and still provide high quality code. And that's kind of the way that we've been with the pandemic, that not everyone's in the office any longer. So being able to work when you want and where you want could be a business requirement of the future. The code reviews, schema changes, unit tests, static code analysis are all carried out by a virtual expert user and as fast as the system allows. So please don't think that this is where you have to start to get the value out of Jenkins, with this enormous pipeline. You can have simple pipelines that have parameters, and those aren't too far away from the ISPF panels and ZVARs that we've used. But because of the power of Jenkins and modern tooling, you can access RESTful API services to automate any existing process. So I talk about the software delivery lifecycle because that's the world I came to BMC from. But you can get value from pipelines with other tasks too. So whilst I focused on software delivery lifecycle, pipelines can do all sorts of other things as well. So at BMC, we believe in an open borders approach to the software delivery lifecycle. We build software that can be integrated with your existing tools. and improve and measure quality, efficiency, and velocity, because measurement is super important. But we look at requests that come from our customer base where they are trying to integrate tools in their DevOps tool chain, and every 90 days we're bringing out new features and functions and new integrations with partners in the digital ecosystem. And this is why the modernization of your existing tools may be the driving force, that you want to get value out of an investment elsewhere in the tool chain. So I've talked my way through the mainframe inclusive pipelines and their value when they were initiated automatically from version control action. And I also talked about how value stream mapping shows how they can significantly speed up the parts of the software delivery process. So in my mind, that's the agility, because you've got the autonomy and the automation to make things go faster. So pipelines are silo busters because they provide the developers autonomy and empowerment, which in turn can fuel engagement and innovation. When autonomous people and teams are empowered to not only establish their own work practices, but also define features, they develop a stronger sense of purpose and engagement. So that leads to greater knowledge, creative problem solving, and innovation. And why should that be important to enterprises? Well, simply put, is that not a competitive advantage? The ability to deliver new functionality before your competitors? It's not about big beating small anymore. It's about fast beating slow. If customers want what you have and no one else has it, well, that's a great place to be for an organization. Modern delivery practices help maintain stability and provide high levels of availability using repeatable processes to release new features and functions. I talked about the ability to practice the deployments has got to be a good thing to help the production environments with their stability and their availability. Ongoing reuse and feedback loops and continuous improvement build up the process until it's dependable and reliable. Regular releases become painless and the new normal. Stability is improved because of the built-in quality gates that only open when automated unit tests achieve the correct code coverage, or the static and SQL analysis meet standards, even with optimized code. But until you've passed all of the quality gates, the code doesn't get to move on through the software delivery lifecycle. And if time and effort is invested in committing infrastructure code to version control and building comprehensive test cases, then the pipelines reduce the dependency on subject matter experts. As I mentioned earlier, the retiring workforce is a problem. So if we codify all of the knowledge that we have into these pipelines, that's going to be better for everyone in the next few years. The pipelines do the repetitive work, allowing any expert to sit back and review, spend some time looking at the data rather than being involved in the day-to-day activities. They can review the data and look at what innovation, what direction it needs to go in. And then finally, throughout the slides, I've talked about automation and the value stream. So if you need any help understanding your current processes or your current value stream, or how the BMC tooling could help in your company with an automated pipeline, then please reach out and start a conversation with me. Thank you very much.